last week's discussed solar cells, design, circuits, efficiency, characteristics, related curves, and everything, and price of the solar cell. Today and next week we will discuss the wind turbine. Everything in wind turbine, the design of wind turbine, mathematical model of wind turbine, the parts of wind turbine. Okay, so this one. Okay, in relation to wind turbine is the wind turbine is a renewable energy source also. Convert the energy from the wind to the electric. Convert the energy from the wind to the electric. Okay, involve converting the kinetic energy from the wind into electric power. Wind turbine are the primary technology for wind energy conversion. Now, the types of wind turbine divided to or classified two types, either horizontal axis wind turbine or vertical axis wind turbine. Depend on the rotor. What is mean by rotor? Okay, I will explain what is mean by the rotor. So there are two types of wind turbine. Okay, there are two types of wind turbine: horizontal and vertical. Horizontal mean the rotor part. This rotor, we suppose this rotor rotate horizontally, okay? But the rotation is called blades, okay? The rotation of blades vertical, okay? But we depend on the rotor position of the rotor position here, horizontal. Okay, this common use this type.
Which is
okay,
vertical,
horizontal, yes, type. While vertical, the vertical is no, is the rotor is vertical. Okay, and this shape is the rotation vertical also. Okay, both vertical, the rotor vertical and the rotation is vertical. Okay.
Does it mean the speed of the horizontal is has more speed, like the speed is, maybe it has more speed?
More power.
Power, yeah.
Okay, more power. Yes, more power. This is a small size, while this is large size. We will discuss the size of the blades, the length of the blades now. Okay. The idea of the wind turbine is the wind passes over the blades, creating, rotating, okay, rotating for the rotor. So we have generator. Most generator used induction generator, double feed induction generator. Why double feed induction generator? Double feed induction generator because there are two feeds to the generator from the stator and from the rotor. So wind passes over the plates, so will rotate the generator and then generate electric energy or an electric power. Okay, the rotor's motion is transferred through the gearbox. Why by gearbox to the generator? Because it's, the rotor, okay, when it rotates, maybe the rotation is the omega angular velocity is slow, so we need to high the speed, higher speed, so should we connect gearbox to transfer the frequency from low speed to high speed. Or maybe we need to reduce the speed. Okay, higher speed, maybe need high speed or low speed. Why? We have T, torque. This term is torque. T, torque in a Newton meter. The torque equal power divided by omega, where omega angular velocity, this omega is 2 pi f, depending on the frequency. So maybe we need high speed. With high speed, so low torque, inverse proportional. Low speed, high torque. High speed, low torque. High, low, low, high. Okay? We know in when we rotate the rotor slow, so we need to connect the rotor, the blades to gearbox. Okay, this gearbox consists of multi-teeth. Okay, this one here, 1, 2, 3, 4, 5, 6, 7. Okay, and here maybe 10 or 12 or okay. Okay. This size bigger than this one. Here low speed. Here high speed. Okay, then this turbine, then connected to the generator. Okay, this is as prime mover. We're using this. We're using this blades as a prime mover to the generator, to rotate the generator. And the type of the generator here, double feed induction generator. Double feed induction generator means this is generator, this is stator, this is rotor, stator and rotor. The feed will come to the stator input and to the rotor. So 2 feeds. Why 2 feeds? We need power electronic converters here. We need rectifier and inverter. Rectifier Y and inverter Y. And here chopper, capacitor with chopper. Chopper, and this filter. Okay. Why we need rectifier? We need rectifier and inverter because you know the wind, variable speed, variable pressure, variable properties of the wind. The wind will change the speed, direction, pressure. Well, the wind turbine depend on the pressure speed, depend on the speed of the wind, the pressure of the wind, and depend on the direction of the wind. So all these properties, 1, 2, 3, pressure and pressure, speed and direction are variables. All these properties are variables. So we need frequency 60 hertz, and we need voltage 120 volts. So from the wind turbine, we will get variable voltage and variable frequency. Variable voltage and variable frequency. It's not satisfied to the. We cannot to connect the wind turbine to the grid. So using rectifier circuit to convert the variable frequency and variable voltage to DC voltage. DC voltage frequency equal to 0. Okay. DC voltage, the frequency equal to 0. Then using the inverter to convert the DC to AC. DC to AC. This AC connected to the transformer. Part of the output of this go to the input. As a feed, as a second feed. And part of this one go to the grid. Let me again repeat this idea. Okay? We have wind turbine. The blades of wind turbine, I will give you the parts of the wind turbine, but now should you know the name of this part or this part of plates. Okay. The wind turbine depends on the wind pressure, wind speed, and wind direction. All of them are parallel. So, wind pressure of the wind, speed of the wind, and direction. All of them cannot to control on the wind. Okay? Speed or pressure or direction. So, first step, connect the output here, mechanical output of the plates connected to gear box. Why? Why? Because we need high speed at the generator side. High speed means high power generator. High speed, high power generator. Why? Because we have torque equal power divided by omega. High speed, low torque. High speed, low torque. Or low speed, high torque. Now, we convert the mechanical speed to another mechanical speed higher or lower than generated by blades or by wind. This first step. Now, we have a problem on the generator. In the generator, we have now reached the generator is variable speed, variable frequency, variable voltage. So variable speed will generate variable voltage. So connect the generator to the rectifier to convert the output voltage from the generator, output variable voltage of the generator, and output variable frequency of the generator to convert to DC. DC with the frequency 0. And okay, we can control the voltage level by using thyristor. Thyristor, we can get the trigger according to the frequency here to get constant voltage. Then connect to the capacitor to filter the output. Now, on the inverter is DC to AC converter. We will convert the DC at this terminal to AC with the frequency 60 Hertz or 50, depend on the standard. In the USA, the frequency is 60. Okay, and voltage, any voltage level, 1 kilo or 500 volts, 300 volts, 120. Then the output of the inverter will connect it to the transformer. Part of the output of the transformer return to the input to the generator as a feedback, and another part goes to the grid, to the national grid, or to the microgrid. Okay? Any question? This is the idea of wind turbine. Okay, the rotor motion is transferred through the gearbox to the generator, and the generator convert the mechanical energy produced by the wind, okay, to the electrical energy. But the electrical energy will variable V, variable F. Okay, but we can convert the variables of voltage and frequency to constant voltage and constant frequency by using set of the rectifier and inverter. The output of the wind turbine is AC, not DC. Okay? AC, not same the solar cell. The solar cell, the output of the solar cell is DC. We need inverter, the DC. We need inverter to convert the DC to AC, to connect it to the grid. But here we need rectifier and inverter. We need rectifier and inverter. Any question, please? Do you need this slide? Okay. Parts of wind turbine or component of wind turbine. This part is the rotor. This is for vertical, horizontal type, but the blades is vertical. Okay, as vertical. 1, 2, 3 blades. We will discuss the length of the blades. This is the tower. Okay, and this is the generator part, controller, okay, and this is the gearbox. Low speed to convert to high speed. Low speed convert to high speed. Why we need high speed at the generator? High speed at the generator means
More voltage, more.
Okay, so this is the part of the main part of the wind turbine. Any question? Mathematical model. This is the main equations of the wind turbine. This value of the power generated. The power generated equal 0.5 rho A V cubic Cv. P is the power output from the generator. Rho is the air density. A is the swept area. What is meant by swept area? Here. This wind power tower, and these plates. Okay. The swept area means this area. Sure, what's the area for this one?
Pi r square. Pi r square.
360 degrees. So 360 degrees.
Yes, but it's pi r square. Okay.
And then the ellipse.
CP power coefficient is already given for the exam. Or, okay, but we will discuss another equation next time. Efficiency should be calculate the efficiency. What is the efficiency? The efficiency is output to input. What's the output? The output is P given by P equal 0.5 rho A V cubic. This V is not voltage. This V is not voltage. This is velocity of the air. Okay, velocity of the air, cubic or wind speed. So this is output power. Okay, so efficiency depend on the length y, and wind speed, also on the air density y. On this equation, rho air density, wind speed, and also blade length. Why blade length? Because the area area A depend on the blades. 1, 2, 3. Depend on this one. Why? Because this is approximately equal to R radius. Approximate, not exact. This R. It's R. Okay, so depend on this. This is the efficiency. Okay. Efficiency is, I'm sure we're looking for the maximize efficiency. Maximize efficiency, we can looking for MPPT. MPPT, same solar cell. Solar cell, we're looking for MPPT. Last lecture we discussed MPPT, max power point tracking, MPPT. And the wind turbine also looking on the MPPT. Okay. Now, sure, the wind is energy is affected by the environmental, and wind energy is environmental friendly because it's a clean energy. Okay, no emissions, no gas, no same same PV or solar cell PV photovoltaic. Okay, also, but wind turbine affected by the wind pressure, wind speed, wind direction. Okay, for standards, these standards available in the global and the USA. Okay, wireless. This is not required for you. Okay, wind turbine dimension. We have high for the wind turbine tower, and we have the swipe area. Okay, swipe area depend on the length of the blade. Should be this blade and this one identical. All of them identical. Same length, same width, same. Okay. So now the dimensions, the tower height typically between 100 to 160 meter, or maybe reach to 200 meter, the height of the tower. Okay. For offshore, this is wind turbine and water, near the water sources. Okay, sometimes they design wind turbine with the solar cell sea or any river or blade length, the range of the blade range between 40 to 85, or maybe reach to 100. Maybe reach to 100, okay? But it should be less than, maximum less than 200. Why? Because when swipe should be less than the tower long, okay? So the turbine is now we have rotor. We say this is the generator, okay? We have length of the rotor, okay? Length of the rotor. I will show you now the movement of the wind turbine and the length of the rotor. Just let me give me the space.
Why
Yes.
wind turbine is not very common? Is it because expensive, the operation?
For vertical.
Yeah,
or-
I mean, not too many, right? For example,
Uh-huh.
why is not too many?
Very expensive.
It's
Yes.
very
Like
expensive.
okay.
Yes, very expensive.
Okay.
Okay.
I think that was millions.
I can install solar cell in my home, but one turbine is
No, it's too much.
that's about, it's too much.
Too much.
Okay, but if I install also, should be the area is open area and should be get approved from the city. Okay, and as example, if we install outside, out of this building, not
Oh,
working. Not working, should be wide area, okay, and should be measure the air, wind pressure, wind speed, and direction for long time, 1 year or 2 years, okay, to test this area is suitable to install wind turbine or no. While the solar cell can install anywhere. Can install outside this building. No problem.
I
Okay.
have a question.
Yes.
So, say for example, you have two power plants that are generating power. One is using wind and one is using solar. Which would be cheaper, I guess, to build a power plant and maintain that?
Sure,
Or is it around the same?
for solar cell, for maintenance, depend, you see, depend. The cost of the installation, the solar cell cheapest than
Okay.
wind turbine. For running, sure, the solar cell cheapest than. For power, no, the power of the wind more than the power of the solar cell. So the power price for wind cheapest than power price of the wind generated. Of the solar cell generated. And for maintenance, for solar cell, sure, is easy and cheaper. Why? Because the height of solar cells maximum the top of the building. You can reach, but for one turbine, no. Some support to reach to the blade or okay, and that in Houston there is a manufacturer in Galveston, okay. So today I couldn't to take video for the they transferred 3 plates from Galveston to anywhere, I don't know where, but through 45.
Oh,
All 45 rush hour.
wow.
Due to because the car, the length of the plates around 40 meters.
Yeah.
Okay, so the car is too long, okay, and supported by some pulleys and some, okay.
Okay.
But the cost of one turbine, 2.6 million now?
Yes, the cost
So much.
more than 1 million.
Two, four.
Yeah. So we cannot to install at home.
No, 2 million.
One, 1 million, 1 million you can purchase this any generator, okay,
Much better.
by 6 or 7,000 to generate all times, okay, or solar cell. Solar cell is but for multi-wind turbine and connected to the grid, no, it's sure it's better than solar cell. Tower height and standard, this one, and legs length, we say from 40 to 85, or maybe reach to 100, okay, but I want to show you this video. There's some types of them. Okay. The rotation of this one, but this is not active. Why? Because see, it should be this plate. Okay.
I want the small.
To get more rotation.
The small fan one, also for to generate.
Yes, this one also is to generate another application. But I want to show you simulation for the EMT. Turbine design. This type is vertical type. Okay, vertical type. And this is common. This is horizontal type. I think some picture is not available here. See this, the internal components of the solar cell, okay, and rotor blade. This manufacturer for rotor blade here. Lightning should be supported by lighting protection. And this is the blade, rotor blades. This one connected to here. Where this one, this same. Okay, joined with the rotor. This is the rotor. This is part is rotor. Okay, this rotor. Okay, and the blades connected to the rotor. The generator. This is the generator. Now, we can visit the solar cell sorry, the smart grid lab to see innovation for the solar cell and wind turbine. Okay, this one is see here, this induction generator, double feed. This is AC to DC converter, and then this copper and capacitor, then connected these